Hello and welcome to the section 1.1 video today. Today we're going to kind of get a look at how the notes are to be filled out, and I'm going to do my best to keep all these videos kind of between 20 and 30 minutes. I think that should be pretty doable. So let's go and get right into it. We have a lot of definitions today, but it's all kind of a review, or should be a review from probably multiple years prior to this. So just going to kind of formalize some of the ideas that we follow when we do some of this stuff. And today is all about solving one-step equations. Okay, an equation is a mathematical sentence. Let's say it's a math sentence with unknown quantities. And a solution is a value for the unknown quantities. Okay, hold on. Handwriting's going bad. Okay. And the way that we solve math equations is by using inverse operations. Okay, inverse operations are a process of undoing what is happening to a variable. Okay, and we'll probably look at another representation of this in the future, but the main idea is if the problem shows addition, the inverse operation of addition is subtraction. Okay, and we're going to use that idea along with what we consider the properties of equality that we're going to talk about here. I'm going to do most of these in some kind of a mathematical sense as opposed to writing them out in words. Yeah, that's just not as fun. So we're going to say that for all these, we have the equation A is equal to B. Okay, and we're going to stick with that equation. So the addition property of equality says that I can add the same number to both sides. So if I take that equation A equals B, I can add C to both sides. Okay? Subtraction property says that if I have that, if I have that A equals B, I can subtract the same number from both sides. Multiplication, same idea. I have that A is equal to B, says that I can multiply the same number on both sides. And the division property of equality says that if I have A equals B, then A divided by C equals B divided by C. With one added condition there, that C cannot equal 0 because we can't divide by 0. So how do we solve equations? We will follow the steps. We will use inverse operations and properties of equality to isolate variables. Wow, gotta spell things right. Okay, and that's a very streamlined version of that, but I'm trying to keep it as kind of as simple as possible. I don't want to overcomplicate things. Okay, so let's go ahead and try a few. And again, I'm focusing on the inverse operations that I have and trying to undo whatever is happening to x. Okay, so if I look at this first one, I see that x plus 7 is equal to 16. Now there's multiple ways at figuring out what x equals. Okay. The most basic way is sort of the number puzzle idea, which is relatively valid, and I'm okay with you thinking of it that way, but I urge you to sort of proceed and sort of, advance enough to where we can understand why it's happening as well. But so the number puzzle idea is kind of saying, well, what plus 7 is equal to 16? And sort of challenging yourself that way to have the number sense to do that. There's going to be times that just doesn't work out, right? You don't know. Like, I don't know. Is it, well, 10 plus 7 is 17. What plus 7 is equal to 16? Like, that's a valid way of solving equations. That being said, it's really hard to when a teacher says, show your work, it's very hard to show work on, well, I just thought about it, and I thought that this plus this is equal to this, so it's got to be, that's got to be the missing number. Okay, the reason that teachers want you to show your work is that eventually it's not going to be that easy. You're not going to be able to think that, in a more complex equation, which we'll get to in the future, you're not going to be able to just think about it from the very first step. So we sort of whittle away at what's happening to x. We chip away things that are happening to x. And when we're doing it in more of an advanced setting, we're starting as far away from x as we can. Okay? In these ones, it's pretty straightforward because there's only one thing happening to x. Okay? So on this one, x is being added to 7. Now, if I use the property of equality, I can undo that adding 7 using inverse operations. In the long form, it looks like this. It says, well, I'm going to take this equation, I'm going to use the subtraction property of equality to say that I'm going to subtract 7 on both sides. Okay, I'm going to do that. And over here, I have 7 minus 7. That's going to be equal to 0. And so that's going to leave me with just x on this side and 9 on the other side. Now, typically, that's not the way that we would show our work because it's, I don't know how to say this the right way, it's more complicated. Most of the time, I'm not going to say that. I'm not going to do it that way. I'm just going to say, all right, you want to say x plus 7, well, I'm going to take that 7 away. In essence, I'm going to move that 7 to the other side. But when I move it to the other side, it ends up being a negative 7, right? Because that's how I pull that 7 from one side to the other. And I know that I'm still kind of overcomplicating this, but I'm using those words very specifically because that's how I'm going to think about more complex equations, okay? I think about moving numbers to the other side. And then when I have to, like in the next one, that 5 is really attached to that x. Okay, so I want to take that 5 off of there. I want to peel it off of there. I'm not moving that 5 to the other side because it's so attached. Okay, so in the case of this 5, I'm going to use the division property of equality, and I'm going to divide it off of both sides. And so when I do that, my 5s actually cancel out because 5 divided by 5 is 1, and now I know what 1x is equal to. It's equal to negative 35 divided by 5, or negative 7. Okay. The next one, we just add 2. By moving that negative 2 to the other side, it turns into a positive. So I'm adding 2 to both sides. And negative 2 plus 2 is 0. And the reason we don't write that is any x plus 0 is the same thing as just 1x. Right, I could say 1x plus 0 is what this side really is, but adding 0 does nothing, and multiplying by 1 does nothing. That's just going to equal -1. In the next one here, I have -8x is equal to 48. Again, that -8's really attached to that x, so I have to divide it off of there. You have to divide that -8 off of there. And -8 divided by -8 is 1. You would say that it's 1x, but 1 times x is just the same as x, so we don't have to say that 1. And then that just equals 48 divided by -8, which is -6. Okay. This one here, I have x being divided by 4. And how do I undo division? I undo division with multiplication. So I'll multiply by 4 on both sides. Multiply by 4 on both sides. And what that turns into, and we haven't written it yet, but it's like 4 divided by 4 times x is equal to -5 times 4, which is -20. And that 4 over 4 is the same as 1, and we don't have to write 1x. Okay. Now the last one here, a little bit trickier, because that that 4/5 is being multiplied by x, so I kind of want to divide by 4/5. Kind of want to divide by 4/5. But we never divide fractions, do we? What do we do instead? We multiply by the reciprocal. We multiply by the same fraction just flipped over. So I'm going to multiply this by not 4/5, but 5/4. And multiply by 5/4. Now, why do we do that? Well, because 5 times 4 is 20, and 4 times 5 is 20. So this side, the fraction on this side, looks like 20 over 20, which is just 1. In practice, what we do is we say that 4 cancels with that 4, and those are both 1s. That 5 cancels with that 5, and those are both 1s. So we have 1 times 1 over 1 times 1, which is just 1x. And here we're just multiplying fractions. If you can reduce, reduce. There's 2 4s and 8, and there's 1 4 and 4. So now I have 2 times 5, which is 10, over 1 times 1, which is 1. And that's my final answer. Okay. So an application type problem that we can talk about here. It says an American flag has an area equal to 9.5 square feet, while its length is equal to 1.9 square feet, or sorry, 1.9 feet. Find the width. Well, if I think about it, the American flag is always a rectangle. Okay, and it says that the square footage of that rectangle is 9.5. And this feels a little bit backwards, but we're going to say that it has a length of 1.9 feet, and we want to find the width. I have a feeling the width is going to be longer than the length. Kind of a typo in the problem, but that's okay. The area of a rectangle is length times width. That's what the area is. So if we put the numbers in where they go, 9.5 equals 1.9 times the width. Well, in order to solve that, I want to divide by 1.9. Divide by 1.9. And I'm never going to say this, even though I didn't use one today. I'm never going to say don't use a calculator. We're at that stage in life now that we can use calculators. Divided by 1.9, and it's 5. The width would be equal to 5. Again, that's kind of mixed up. I would probably say that the width is 1.9 because our flag goes this way, right? It doesn't go vertically, but the width is 5. The width is equal to 5 feet. And there we go. So make sure you write a quick summary of your notes, say something that you had. And if there were any questions that you had, make sure that you write them over in this space over here. Okay, any questions? And you ask those questions when we come to class. Okay, that's the way these notes are to be filled out. Other than that, I hope you have a great day, and we will see you in class.